The next problem we're going to cover in our random little jaunt through question number 10 is letter F. Letter F is a bit of a departure because letter F is going to ask us about some things that you might have already kind of picked up on right off the bat that don't seem like they quite jive with the given information. The information at the beginning of the question in a couple of videos ago inspired us to highlight and think about what we already know. For example, that the area of F is 18, the area of G is 5, the area of H is negative 11. All those things are great. And they all referred to the same areas from negative 2 to 5 on each distinct graph. But question letter F sort of looks different for one glaring reason. Its integral is from 0 to 7. And you might be looking at that going, what the heck? How am I supposed to think about that? And it's talking about h parentheses x minus 2. We have definitely never seen parentheses with x minus 2 before. And if your temptation is to say, well, I'll just split it up. It's got a minus sign. I'm going to ask you to pump the brakes on that for a moment, because I do hope that you'll notice the inherent difference between letter E and letter F. They both have a minus sign, but notice where the minus sign is. In letter E, the minus sign was after the parentheses x. We were allowed to split this one up because f of x as a standalone item was something that we knew something about. We knew f of x, so we could split it into a separate integral. We knew the 6. We could separate it. This does not separate in the way that you would think. H of x minus 2, if you think about this in the traditional function notation, isn't h of x minus h of 2. That's not how function notation works. And h is not distributive in that way. So we might be a little bit limited with our thinking right now, saying, okay, well, if I can't split it up, then what am I supposed to do? And how in the world am I supposed to deal with the 0 and the 7 anyway? But I'm going to implore you here to think about the fact that if the 0 and the 7 don't match with anything we know about areas, if the 0 and the 7 don't seem to be anything like what they gave us, let's step away from the given information. And let's try to think a little bit critically. I'll admit my logic in the next little step might seem a little bit of a reach at first, and if you're wondering where I'm going with this, you might have to bear with me for a couple of moments if you're not really sure where I'm getting this from, but I think you'll kind of notice pretty quickly why I'm doing what I'm doing. So bear with me for a moment, and I'm going to ask you to think visually. It seems like a trick question. How can you think visually about a question that didn't give you any pictures to envision at all? But let's just kind of visualize what we can with the limited information we have. We do know that the h function, which I had highlighted pink at the beginning of my little foray here, the h function is the one that goes from negative 2 to 5, and it has an area of negative 11. So I'm kind of picturing a hypothetical graph. I have no idea what it would look like, but I know that from negative 2 to 5, whatever that is going to be a negative 11 somehow. So I drew it underneath the x-axis to make it negative, but notice I just kind of made up a weird wobbly shape. I have no idea if that's correct or not. I'm just making it up. Now, what does that have to do with this problem that we're trying to do? Seems like nothing, because this one asks me to go from 0 to 7. It's not convenient at all. 0 isn't even an x-coordinate that I've thought about on my graph. 7 is definitely not an x-coordinate I thought about. I stopped thinking about x-coordinates once I got to 5. So how in the world are they supposed to ask me about an area that I can't see if they're not even giving me something to pretend I can visualize? I mean, I'm pretending to visualize this, knowing that's a stretch, but I can't make up what they didn't tell me. I can't make up what's going on from 5 to 7. I have no idea what's going on there. So then you might have to think, what else? Where else am I supposed to pull information from? And it's the structure of that h minus 2, or h of x minus 2, sorry for the confusion there, h of x minus 2, that hopefully kind of brought to mind the fact that you have seen this structure before. Now, it might not have been recently, certainly might not have been something you would have thought of on your own, but you've totally seen this before in your algebra classes. Remember way back to Algebra 2, maybe even Algebra 1. We talked about way, way, way back in those early days of understanding function notation, the fact that h of x minus 2 is actually a transformation of the h of x function. We usually talk about this stuff when we talk about graphs. when you shift a graph to the left, to the right, up and down, you're usually dealing with this notation. Specifically, when you have an x minus 2 inside of the parentheses, inside of the function, that represents a horizontal shift of the function. If this is slowly coming back to you, you might be going, oh, right, yeah, like parabolas and stuff? Yes, like parabolas and stuff. That's exactly where your brain could be going right now, and that's wonderful. Because when you see an x minus 2 inside of parentheses like that, like x minus 2 squared or whatever, that's really to remind you that this graph is being shifted to the right 2 units. And if that kind of made you stop and go, wait, what? Right? X minus 2 to the right. Then hopefully you'll remember that was a thing in Algebra 2. That was a thing that we dealt with all year long. That the inside number in those parentheses always did the opposite of what we'd expect. If it's at x minus 2, it shifted to the right 2. If we had a different function, and I'll just make one up for a second, f of x plus 7, that actually shifts the graph to the left 7. Counterintuitive, for sure. But if this rings a bell and you're like, oh, I do remember seeing that, then hopefully you thought about why shifting the h graph to the right 2 actually is the key to unlocking the mystery behind this question. Why in the world were they asking me about 0 and 7? Why in the world were they giving me a problem that seemingly couldn't be done? Because they wanted me to realize that this was just a shift. That if I take my h graph, and again, I just made up the h graph. I have no idea what it really is, but if I take my hypothetical h graph, whatever it is, and I shift it to the right 2, picture what it would look like. Kind of just drawing it in this color so you can see it jump out to you, but notice I'm very strategically trying to mimic the exact same shape I drew before. Because, do you notice something? When I shift it to the right 2, notice where its new endpoints are. I shifted to the right 2, now the graph starts at 0. I shifted the end of the graph to the right 2, now it ends at 7. And that's the exact same set of x coordinates that they wanted me to find the area of in the first place. Sure enough, that was why. They weren't giving me an impossible problem, they were just forcing me to think about that transformation. They were forcing me to realize I needed to shift my existing graph to the right 2. Now, keep something else in mind. I haven't changed the actual physical size of the graph. I shifted it, I moved it, but that negative 11, whatever wonky shape that is still negative 11. So the area hasn't changed. The answer to this problem actually is negative 11 because the physical size of that region hasn't changed one bit. I shifted it to the right. It gave it new endpoints, but it didn't change the physical size or dimension of the shape itself. And again, I don't even know what that physical size was to begin with. I just know that its physical size had an area of 11. So, moral of the story, this is a shift problem. It's telling you where to shift by giving you this kind of encoded little bit in the parentheses. It was telling us to shift to the right 2. And, not coincidentally, that put us exactly where we needed to be regarding the limits. From 0 to 7, yep, right 2, that takes us exactly where we need to be. So perhaps not surprisingly, if you link question letter F and the logic involved there to question letter G, you'll probably be able to figure out pretty quickly how to do letter G. Because on the surface, letter G looks incredibly complicated. How in the world am I supposed to do an integral from negative 4 to 3? They didn't give me negative 4 to 3, but now we know. There's a reason. They didn't ask us to go from negative 4 to 3, but they're giving us enough of a clue to take information we already know and to shift it strategically. So between now and the time that you watch the next video, apply this information to letter G and give that one a go. If it doesn't really make sense, if you're still kind of fuzzy on the logic behind the shifting thing, then definitely take some time to marinate on that. That's not a major idea in calculus. That was an algebra idea for sure. But once you tap back into that part of your brain that did at one point learn that long, long ago, hopefully it'll sound familiar enough that the idea will make sense. In the last video for this specific problem, we're going to do question letter I that brings all the ideas together. So between now and the time you begin that next video, finish letter F, making sense of that, finish letter G, check your answer on that, and then we'll put it all together in letter I.